In this video, I'll be covering question 2, part B from the 2018 AP Calculus AB free response calculator required portion of the test. I cover A, B, C, and D all in their own individual videos, so if you want to see those other answers, feel free to check out my other videos. Alright, so on part B wants us to find the position of this particle at time t equals 3. When we look back at the original information they give us, they told us that the original position of this function at t equals 0, so the initial position, is at -5. And what we want to add to that is we want to add the total displacement. So from there, how much did we move forward and backward, and where did we end up moving from that -5? To find total displacement is your standard definite integral. You would take the integral from a to b of whatever your velocity equation is, dt. So on this problem, the setup that we would be looking at would be -5 plus our lower bound. We're looking for what happens in the first 3 seconds, so from 0 to 3, and then the velocity equation was given to us at the start here. So 10 sine of 0.4 t squared all over t squared minus t plus 3 dt. Now what we need to do is just go find the value of that definite integral. And the great news for us is we are on a calculator required portion, so we don't have to do that by hand. We're actually just going to shove this into the calculator to get out the answer. So what we'll do here is in y1, we're going to put that equation. So 10 sine of 0.4. And when you go into the calculator, you want to kind of change over whatever variable they're working with into x's. So I'm replacing everything with an x right there. Then after step 1, step 2, you'll go ahead and hit the graph button. And then step 3, we're going to hit second, calc, and then inside that calc menu, you'll choose the number 7 option, which says integral of f of x dx. We'll answer a couple of questions, and after that, the calculator will spit out the answer for us. The integral of f of x dx equals, and whatever that is, we'll add to -5. So let's go ahead and open up our calculator. You'll go into your y equals, which is the button in the top left, and one of the greatest buttons they added onto these calculators was the ability to split up a fraction when you type it in. So when I need to type in a fraction, I can hit the alpha button and then the x button just beside it, and that'll split that into a fraction for me. So I can just type it in exactly how it looks. If your calculator doesn't have the alpha x move, that's one of the more recent calculator updates. From there, usually what you can do is hit alpha y equals up at the top, and this will pull up this menu, and you just want to hit enter on number 1, that numerator denominator, and that'll split that into a fraction for you. If you're absolutely terrified of these fraction buttons or don't have them, then when you enter a fraction into the calculator, make sure you put the whole top in a set of parentheses divided by the whole bottom in a set of parentheses. The calculator is very literal with its order of operations, so make sure you do that if you need it. So from there, I'll type in this equation. Remember, this whole test is in radian mode, so whenever you're using trig functions, make sure you're in radian mode. You should just set your calculator radian mode and never touch it because, like I said, the whole test is in radian mode. So once we enter that into our y equals, we'll graph that. And now we're going to do a second. We'll choose the calc menu, which is the button above trace at the very top. And then inside there, we're going to see that number 7 option, integral of f of x dx. I hit enter on that. And at the bottom of the screen, it's going to ask me a couple of questions. The first question says, what's the lower limit? That's our lower bound, which in this situation would be 0. So I type in 0, hit enter. It's now going to ask me for the upper limit, which is our upper bound, so that would be 3. So I type in 3 and hit enter. It shades it in, and then at the bottom of the screen, that is my answer. It says integral of f of x dx equals 3.2397, so 3.23978 something, right? 86. On these tests, usually when you aren't at your final answer, you kind of want to take it out to 6 decimal points and then work from there. So that was our integral portion. That was this piece. That's how much from our starting position we moved. So what we'll do now is we'll take that starting position, -5, and we'll add to it what that displacement was, which was the 3.239786. And once we add those two things together, that will be our final answer. So I open up the calculator. One of the great things about these calculators is that answer, that work that you've done, that is stored as the answer in your calculator right now. So one of the quick ways to do something like this is to just hit the plus button, and now it says answer plus. So that answer is the 3.239786 number, and we just want to add to it -5. I hit enter and that gets me -1.760. So when you're doing it on the final answer, you want to go to 3 decimal places. And so that's our position after 3 seconds, or at t equals 3. So on this problem, we would have gotten 3 points off of here. 1 point from setting up our definite integral up at the top, 1 point for adding it to the -5 right there, and then 1 point for putting it all together as the final answer. So 3 points on this question. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.